Hello and welcome to the fifth lecture of seventh chapter of our comprehensive course on artificial intelligence, machine learning, and data science. Now here we are actually doing in this chapter this data wrangling with pandas, and so far we have done somewhat somewhere we were okay. First, what does data wrangling include? Yes, that was here. Okay, so it means handling missing values, non-imputation, data type conversion. These two we have done, outlier detection and outlier removal if required. Okay, so then that also we have done. Now we are doing this duplicate detection and deduplication. Duplicate rows detection and deduplication means removing the duplicate rows. Each row is also called a record in the database or data set. So then we want to find what records are duplicated, and the reason is that the duplicated record do not add anything to the predictive power of the model, but they actually skew the database data set towards the population sample will be skewed towards that duplicated rows. Okay, so let us see what is the meaning of what I just now spoke. Okay, then here let us first create a data frame using dictionary. So we all know that using dictionary, when I say, that means these all are column names. Keys become column name, last key is customer ID, and the values, this, they become individual records or individual rows. So these are the records which are to be put, or values which are to be put in price column. Similarly, these are the values to be put in date column. You can note this, that we have converted the values into date time variable using one such function, pd.to_datetime. Now this function is important to remember, because many time in data science we have to deal with date time data. For example, you are doing a busyness analysis of a airport like Mumbai or Heathrow, where hundreds of flights take off and hundreds of flights land daily. So based on how busy the airport will be at a particular day, on a particular day and a particular time, you can allocate the airstrips to various different airlines. That is also called a predictive model, and that is application of data science. But if you don't keep it this way, that means you just simply remove this pd.datetime and just provide this list. Then also a data frame will be created, because for creation of data frame, what we require is just a simple key and values. Values, if only one record is required, then only one value. But if say many records are required, then a list is kept in the values. So that is fine. Here you are providing that. So let us see that data frame is created or not. Yes, it is created. However, this just looks date, but it is not date actually. It is just a string variable. So if I can show you also that thing, that I can add one line, print df.dtype. Yeah. And then this. Now if you see, product ID is integer, that is integer, sales is float, price is float, date is object type. Object means it is a string type. Okay, and customer ID is float. Now the problem with this is that if you want to find duration, say one particular flight has from one airline has come at this time, this date, and next it has come on this date, and you want to find the duration, that after how many hours or after how many days that airline flight lands, so that you can allocate the airstrip to that airline in quickest possible manner, because passengers would not like to just keep on rotating in the air and waiting for airstrip. Okay, so that at that time duration will be when this minus this, next landing minus previous landing. But can I do this minus this on a string? Because it is meaningless. For a string variable, addition subtraction is very meaningless. So what you have to do is you have to write pd.to_datetime and then enclose everything in a parenthesis. So perhaps here there should be one close parenthesis. I think it should work. Now date spelling is wrong. Okay, then invalid syntax, one comma is missing. Where the comma is missing? 19. Okay, so here last one comma which I removed. Let us keep it. Then no, that was not the problem. No, last comma is in fact not required also. Yeah, here at the end outside, because this is just one column, but I have to add another column. Okay, fine. Still problem. What is the issue now? Okay. Oh, there was another parenthesis hidden. The row is very long. That is creating the trouble. Okay, now I think hopefully, yes. Now if I see the data type, then data type is date time data type. Okay, now I can do final date minus initial date and find the duration after which the flights, or the period after which the flights descend. Okay. Here also you can see the D types and you can find. Here already I added it in previous one, so I am removing this. Now rows to duplicate. So this was a data frame which I created just for our study, and currently it has no duplicate rows. But I want to first introduce duplicate, because then only I can learn how to detect the duplicates and how to remove the duplicates. So I take that I want to introduce these first four rows as a duplicate rows. So what I do is first I create a new data frame of only those four rows. So this is the new data frame of only those four rows. Okay, this, and then I concatenate my original data frame, that is this with my new data frame, this, and for concatenation the method is pd.concat ab, where in the square bracket, that is a and b are the two data frames which you want to concatenate. And if you want to concatenate one above another, then write in ignore index equals true. If you want to concatenate one on the right side of another, then write ignore index equals false. So that means here I am using ignore index equals true. So I can see that concatenation has occurred and these four rows are exactly appearing here. Okay, only the row index is different, but index is not part of data frame. Data frame starts from this column. Okay, and the values in each and every column for these four rows match with each and every column of these four rows. Okay, so that means every feature is matching. That is the meaning of duplicate rows, that all columns of these row and all columns of these row, they are identical in value. Okay, similarly all columns value in this row, second row, should be equal to all columns value in this second row, third last row, like that. Now how to drop the duplicate? Then dropping the duplicate is done in this manner: df dot drop duplicates. Actually duplicate is a very easy, deduplication is very simple. There are only two functions which one has to remember. One is df dot duplicated, okay, and second, that will give me which rows are duplicate and which are not duplicate. And once you have decided that there are duplicates, then you will write df dot drop underscore duplicates. That's it. Only two functions can do almost everything in deduplication of data frames. Okay, now here I want to first write that df dot duplicated. Okay, let me see if there are duplicate rows or not. Here I myself introduce the duplicate row by appending first four rows at the bottom, so I know that there are. But suppose a new data frame comes, you have loaded a new data frame from a database or a file by pd.read underscore csv, and it has maybe 1 lakh rows. Then this kind of visually seeing all those rows and finding duplicate rows, that is not possible. So are there any duplicate rows? First you have to check it, and for that the function is df.duplicated. If you do that, then it gives a false or true beside each observation, each record. So that means false means that record has no other duplicate record, but true means that record has some duplicate record, like this. Okay, so here you can get that this record is duplicate of some other record. Okay, so these last four are duplicates of some other record. So that's how we detect it. Once detected, I have to drop it, for which I just write df.drop duplicate. Okay, but if I just do this much, that will drop, but that will not store it anywhere. So I have to store the result somewhere. So I am storing it in a new data frame. Suppose I call that new data frame df unique, and I will then print df unique also. So if you do df unique and print it, then you can see that now again those 12, 13 who are duplicate rows, they are removed, and only 0 to 11. Now someone may argue that why only these are removed? These are all this it means this could have been kept, and the top four could have been removed, because ultimately last four were just duplicates of those top four. That is how we introduced the duplicates in that. So any can be removed, but the default behavior of drop duplicates function is that it keeps the first occurrence of duplicated row. In fact, default behavior of duplicated function is also that it does not detect the very first occurrence of duplicated rows, but if same rows occurs again next, then it starts detecting. So it starts detecting true here only. And similarly, dropping also occurs when second occurrence occurs. The first occurrence is not removed, because if both are removed, then you can understand if this is also removed and this is also removed, then you are losing the data. Okay, so if top four are also removed and this 12 to 15 are also removed, then you are losing the data. So at least one occurrence should be kept. So the default behavior in short is to keep the first occurrence and remove the last occurrence. Okay, now I think this I have already done. So I can delete that. Identifying also I have already done. Dropping the duplicate also we have done. Okay, fine. Now here I told you that drop duplicates is actually much powerful method. So let us again create a data frame and let us print that data frame. Uh, I should have kept this each in different cells because that would be easier for understanding. So let me cut this. Okay, so I just reshuffled a few pieces of code to the next lower cells so that I can clearly explain step by step. Otherwise, all outputs would be printed exactly here, and therefore only I had to provide this line, which is now not required, to separate the outputs from each other. So now this is just first creating the data, and the data should be having some duplicate rows. Okay, so this is the data. Remember, not data frame. It is a data in the form of dictionary. So when we convert it into pandas data frame, this will become the column headers and these would become the rows. Records in id column, these would become the values in name column, these would become the values in age column, and so on. So let us create this data frame. This function is our welcome pd.dataframe, dnf capital uppercase, and in bracket the dictionary which you have created in previous step, and print the data frame. So you can see that this is my original data frame, and maybe there are some duplicate record here. This is id alice 25 math and 100, 1 alice 25 math 100, 2 Bob 30 science 200, that has no duplicate. 3 Charlie 35 math 100, 3 Charlie 35 math 100. Then Eve has no duplicate, David has no duplicate, and okay, fine. So two rows are duplicated. One is this Alice with this Alice, and one is this Charlie with this Charlie. Okay, fine. Now these rows which are already containing these selected rows, to create, why are we appending as such? There is no need to append anything. They are already appended. Data frames are already appended, and there is no need of appending rows to duplicate here. Okay, so this was actually previous thing. Okay, now drop duplicates can be used in different manners. So this is the first manner, that you just use data frame dot drop duplicate, drop underscore duplicates, without any option specified. Then it will do its default behavior. That means it will keep the first occurrence of Alice, that is index 0, will be kept, but the second occurrence, index 4, will be removed. And similarly, it will keep the first occurrence of Charlie, this line, so 2 will be kept, but this index will be removed. Okay, so then here this says that this is how you can, first occurrence of this is kept, but second Alice has disappeared, and first Charlie is there, but second Charlie has disappeared. Okay, and the observations are 5, 2 less. Here how many observations you can count manually? Then 4 and 4, 5, so 9. Here how many are there? So then 3 and 3, so 6. So I think something more was also duplicated, and that has been removed. Maybe just a minute. 4 and 5, 9. 4 and 2, 6. So which other was duplicated? Alice was duplicated with this Alice. Charlie was duplicated with this Charlie. There is no other duplicated row. Okay, let me write print df dot duplicated. Okay. And I'm getting that 2 occurrences are there. So fine, I think that only 2 should reduce by 2. Okay, so drop duplicates. Now how many are there? Then 1, 2, 3, 4, 5, 6. Here how many were there? Then 1, 2, 3, 4, 5, 6, 7, 8. Yes, now it is correct. Actually, I don't know what I was counting. Maybe I was counting the header row also. Sorry. And now if so, default behavior is to keep the upper row which is having its duplicate, but remove the duplicate which is occurring below it. And similarly, upper Charlie is kept, but the lower Charlie is removed, so that you can see here. Okay, upper Alice and upper Charlie are kept. Now if I want to explicitly keep upper row, then I can also write keep is equal to first, though there is no need of that, because if you don't write anything, then also same thing is going to happen. But let us just check that whether I get the same output or not. So these output and these output, these two are same. Okay, fine. Now keep last duplicate row, so that keeps the last occurrence. So at that time, drop duplicates, keep equals last. So at that time, this was my original data frame. This was my original data frame. I am removing this duplicated now. Okay, and last I want to keep. So then this will 0th index row will be removed, because there is this last Alice is here, and similarly second index Charlie will be removed. So 0 and 2 index should not be visible in the result because index 5 is also Charlie. So if I keep that and print it, and now there is no need of this separator. Okay, so then I will get this. So you can see 0th index is removed and second index is removed. So upper Charlie, upper Alice and upper Charlie are removed, lower Alice and lower Charlie. So last occurrence has remained. Now, if you don't want any, that is topmost also and bottom also. Again, I am just keep bringing you back here, original data frame. So this is Alice upper or first occurrence and Alice second occurrence, and this is Charlie first occurrence and Charlie second occurrence, like that. So then I want to remove everything, though that is not a desirable behavior because you will lose your data. But sometimes you may require some if that kind of behavior, then use keep is equal to false. So keep is equal to first will keep the first rows, first occurrence of duplicate rows. Keep is equal to last will keep the last occurrence, and keep is equal to false will not keep any occurrence of duplicate row. That means it will delete all occurrences. So now only this much is left. Okay. Then delete duplicate row based on specific columns. Now this is slightly more practical way, because here so far duplicate means when I say two rows are duplicate, that means they have same value of every feature. 1 Alice 25 math, okay, and similarly here 1 Alice 25 math 100, but and similarly 3 Charlie 35 math 100, 3 Charlie 35 math 100. But sometimes you may consider that rows are duplicate if only not all columns are having same value, but any given column, say name and age, are having same value, or maybe course and fees are having same value, like that. So then also it is easy. The method remains still drop duplicate, but you first select subset. Here you don't specify any subset, means your duplicate should be all the rows which you identify as duplicate for dropping. They should be exactly duplicated in all columns. But here you specify that my rows should be duplicated only in these two columns, courses and fees. Okay. So if you want that, then in that case you can do this kind of thing. And now empty data frame is obtained. Empty is obtained, that means perhaps if I see the original data frame, then courses and fees, why empty I am getting? These were the columns, right? So oh yes, yes. To understand this, why you are getting empty data frame, first let me print original data frame once again. So this is my original data frame. Now if I use drop duplicates just and keep is equal to false, then I will drop all the duplicates here, the last occurrence of duplicate, here the first occurrence of duplicate. But if I just use drop duplicates without specifying a subset of columns, then it will consider a row as a duplicate provided value of all columns in one particular row are identical to this, are identical to value of all columns in some other row. So here I have to first match the values in each and every column, and if each and every column value match, then those two rows qualify as being called a duplicate. But here in this case, that is this case, when I specify a subset of columns, then that means if values in those two columns match, that is enough to qualify the row as a duplicate row. Okay, so if my original data set, which was like this, and my two columns were course and fees, so if I see math 100, but math 100 is occurring here also, and math 100 is occurring here also, and here also, total 4 times. So will you consider them duplicate? Yes. Okay, now that means, and I am using keep is equal to false. So keep is equal to false means remove the first occurrence also and last occurrence also. So all the occurrences with math will be deleted. So now what is remaining is science. Let us check. Science course and fees 200, but here also there is science course and fees 200. So as far as these two rows are concerned, they are also duplicate because I don't have to bother about other columns. I have been given a subset of columns, course and fees. So these two are also duplicate, and keep is equal to false is written, so I will delete them also. So everything with math is deleted, everything with science is deleted. Now what is left only is history. So history 300, but here also history 300. So even everything with history will also be deleted. So what remains is nothing. So that is the reason why I get empty data set. Okay, fine. Now this is also one good example that dropping the duplicate rows in place. Now this somewhere earlier we dropped the duplicate rows, but at that time I said here. Okay, so we created one data frame, we concatenated the first 4 rows of that same data frame. So this was the original data frame. These are the first 4 rows. We concatenated the data frame and the first 4 rows with ignore index equals true. That means we concatenated one above another. So some duplicate rows are here, these four, and the last four, they are exactly matching with each other in this kind of scenario. Okay, so there we introduced duplicate, then we even checked also, then first occurrence is not counted as duplicate, so last occurrence shows that yes, true, these four rows are actually duplicate of some other rows in the data set. Okay, and then we use drop duplicates, and finally there is but if I just use df dot drop duplicates this way and then print df, then you will see that duplicates will remain. Okay, so first let me bring those duplicates. So this is my original data frame. These are rows to duplicate. These are appended. So now this is a data frame with duplicate, checking that yes, last four are duplicated, and then df dot drop duplicates. So the last four drop duplicate function I had provided, but it could not drop. What has happened? These are the top four, and the same are remaining here. What is happening? Is this drop duplicates function or this code wrong? No, the code is right. But when you drop duplicates in that manner, it is just dropping duplicate temporarily, but it is not saving the new data frame anywhere. So that is why you have to do that. That we had to save the value in a new data frame, df unique, and rather than printing df, now I am printing df unique, and now you will see that those duplicates first occurrence is kept because that is the default behavior, but the last occurrence where 12, 13, 14, 15 index was there, they are gone. Now the question is, suppose I don't want to store in a new data frame and that df unique and all that, I just want to drop duplicates and that's it. So then there is one such option. If you don't do anything, then drop duplicates will work, but it will not store the modified data frame anywhere. But if you write this in place is equal to true, then thereafter if you print the data frame, then you will see that you will get the desired result. Okay, so now top occurrence has remained, but the bottom occurrence 12, 13, 14, they are gone. Okay, so this in place is equal to true is a very important command in Python to modify a data frame in place. The name itself is clear. In place means you don't need to save the data frame in a new data frame. Like for example, here earlier what we do, df dot drop duplicates, and then we stored it in df unique or something like that. Somewhere, where is that? Yes, here we saved it in df unique so that we can print the modified data frame. But in data science, often we don't need to, or it is not good to create new data frames every time. We want the name of the data frame df, and then in next step also df only, and next step also df only, because after dropping duplicates you have to do other steps, maybe finding outliers, maybe imputing for non-values and all those. So at that time df should remain df only. So then don't store the result of all this in a new data frame. Instead write this in place is equal to true. Then that is like this, df is equal to df dot drop duplicates, like this. You can check also that this will also give the same result. First let me introduce duplicates. So this is my data frame and this is my duplicate rows, first four rows, and now no, these are drop duplicate has occurred. Okay, somewhere, where is that? Okay, yeah, here it is. So this is my original data frame. These are selecting the top four rows to duplicate. These are concatenating the two data frames one above another, so that I am getting this data frame as df. Now I am directly skipping the intermediate steps and coming to this cell, df dot drop duplicates. Here it was in place is equal to true. Now instead of that I am saving the result in df itself. That is also giving me desired result. Okay, so in place is equal to true is nothing but execute this function and store the modified data frame in original data instead of original data frame only. Okay, so another way of doing this is writing this way. Okay, just write this and you will get same. Now first I have to again create the duplicates. So this is the original data frame. These are the rows which are to be duplicated. Here I am appending. So now this is the row data frame with duplicate records. Directly jump to that line, in place is equal to true, and you will see that red warning and etc. will not be seen directly. You will get it proper. Okay, fine. Then one more thing is recreate the this is just for recreating the original data frame. So let us recreate the original data frame, and instead of printing this, let me print the original data frame itself. Okay, so this is my original data frame. Currently it has no duplicate. Now I can apply any function to my original data frame using dot apply and lambda function. Now this lambda function is a new concept and it will come much later on and we will study in much detail. I think so, perhaps we have done it. Yes, we have already done it while doing list comprehension and some other things. This is like that only, list comprehension and other things. But this is also, say, there are Python has certain features which make it very powerful programming language. One is list comprehension, dictionary comprehension. Similarly, this lambda function. So when you use this, that this x is my data, df is my data frame, and then I can write df dot apply x where x dot str, then str dot lower, then drop duplicates, subset, courses, fees, keep is equal to first. Now this part is what we understand because in this the whole chapter so far, in this lecture at least, we are discussing these only. But what is this part? So here it says that before dropping duplicates, consider only this column as a subset. So that means if these two columns values are matching, then consider the row as a duplicate. This time I have not written keep is equal to false, otherwise both first occurrence and every occurrence of duplicate would be deleted. But keep is equal to first means keep the first occurrence but remove the other occurrences. So course and fees should not be there actually. Maybe I think I should create that data frame once again. Okay, wait. Okay, I had some other data frame recreate the original data frame for next example. Now I have created appropriate data frame. So these are course and fee column and I have selected that as my subset. So if values match in those two columns, then I will consider duplicate row. So this is duplicate of this and these. So only the first occurrence will be kept, means index 0 record will be kept. Similarly, this science 200 and this science 200, they are duplicates. So only this will be kept, means 0th and first record will be kept. Then this math is already history 300 and history 300 are also duplicated. So this record will be kept. So that means 0th index, first index and third index. These three records will be kept after drop duplicates and these. But this example is meant to show that drop duplicates is so versatile that it can even use apply and lambda function we can also use apply and lambda function in combination with drop duplicate. So this is that apply and lambda function. Now what this is doing, this is taking x where x as a type string. So that means from this course and fees, it will select the course because that is in string, this is in number format, okay? And then it will convert that string into lowercase. So now math will be small m, small a, small th. This second record will also be a small scinc and this record will remain. So then that will be histury, small, all small letters. And then drop duplicates, or before we have already dropped duplicates for understanding at least. So then we know that these will remain, first occurrence should remain, and history first occurrence should remain. But answer will have only lowercase letters in the courses column. So let us see if I am getting that or not. And yes, I am getting math all lowercase, science all lowercase, and history, and also 0, 1 and 3 as expected. Only the first occurrence of duplicated rows are coming. This shows the power of this drop duplicate function, that it can be preceded with any other function, and it can be apply is usually used to apply something to entire data frame, but here entire means after dropping the duplicate whatever records remain. So these three records we are applying this function, and this lambda we can write a function separately and then call that function and all that, but this lambda is a method in Python to on the fly create a function. On the fly create a function means sometimes actually the basic purpose of defining a function is that you can call that same function again and again and again and again. So code reuse, that means that you don't have to code the same functionality every time you need to use it. But some functions are such that now this is a specialized application that you just take a string and convert it into lowercase. You don't want that I will need to use it in again and again for various different purposes. So then I just need this function once and then that's it. So lambda function is a transitory function or a on the fly created function which remains in existence only as long as this line is executing, and thereafter it automatically stops occupying memory. So that is one powerful feature of Python, and we will do very detail of discussion of this lambda function. So if you don't follow everything, don't worry, because the purpose here is not to teach lambda function and apply, but the purpose here is that drop duplicates is a method which can be combined with apply and lambda function. Okay, in next lecture we will be doing this, identifying and dropping single valued columns.